ward force of its weight, achieved by accelerating to a specific takeoff speed, VR or rotation speed, on the runway. The required speed varies significantly based on aircraft size, weight, and environmental factors, but for commercial jets it's typically around 240-285 km/h, while light aircraft may only need about 100 km/h. This speed is reached by the engines providing enough thrust to overcome drag and friction, allowing air to flow faster over the curved upper surface of the wings than the flat lower surface, creating a pressure difference that produces lift. Why an airplane needs a specific takeoff speed? Generating lift. The core principle is to achieve sufficient lift to overcome the airplane's weight. Lift is created by the shape of the wings, airfoils, and their interaction with the air. As the wing moves through the air traveling over the curved top surface moves faster than the air traveling under the flatter bottom surface. Bernoulli's principle. This principle states that as a fluid's, like air, velocity increases, its pressure decreases. Therefore, the faster moving air on top of the wing results in lower pressure than the higher pressure on the bottom. This pressure difference creates an upward force, or lift. Thrust and speed. The airplane's engines provide thrust, the forward force that overcomes drag and accelerates the aircraft down the runway. The faster the airplane moves, the greater the airflow over the wings, and thus the more lift is generated. Takeoff speed, VR. The aircraft must reach a specific speed known as rotation speed, VR, to generate enough lift. At this point the pilot pulls back on the yoke, increasing the angle of attack, the angle of the wing relative to the airflow, which further increases lift and causes the nose to rise and the wheels to leave the ground. Factors affecting takeoff speed. Aircraft weight. A heavier aircraft requires more lift and therefore a higher speed to take off. Airport altitude and air density. Lower air density, due to high altitude or temperature, requires a higher takeoff speed because the wings need more air to generate the same amount of lift. Headwinds. A headwind provides extra airflow over the wings, reducing the ground speed needed for takeoff. Engine performance. The power of the engines and the aircraft's design influence how quickly it can accelerate. Flaps. Flaps on the wings can be deployed to increase lift at lower speeds, allowing for shorter takeoff runs, especially when there are obstacles to clear.